Hello everyone. Welcome to Daily LeetCode Live Coding. I'm coming to you all pretty late today, at least on Eastern time, and I'm going to be making this a short one because I got a little bit caught up. I had some events that I needed to go to. You know, it's Friday. I like to spend time with friends and family, and I'm just back home now. So I did want to come and at least sneak in some time for a LeetCode live stream. So it's going to be a short one, maybe 20-30 minutes. I know it's not usually the time limit that I do it, but it is what it is. So let's get right into it. We are sitting at 283 questions. We're going to be continuing on with easy questions on page 4. Let's see the next spot that we have to hit. So I think last time we tried doing degree of an array and diameter of a binary tree, but since these two were sort of, we didn't get a chance to do them, let's see if we can at least do one or two for this stream. Let's see what our first one's going to be here. So we define the usage of capitals in a word to be right when one of the following cases holds. All the letters in the word are capitals, like USA. All letters in this word are not capitals, like LeetCode, or only the first letter in this word is capital, like Google. Given a string word, return true if the usage of capitals in it is right. So it's either going to be all uppercase or all lowercase. Now, I guess, let me think about this one. I almost feel like it'd be nice if we just check to see. Let's see if like all this was the same and all this was the same. Like if all of them are lowercase, let's think about this. They can all be uppercase. If that's not the case, let's see. What do we do in each one of the different scenarios? If it's uppercase in either of them, so if the first character is uppercase, rest is either upper or lower, or all are lower. So I mean, we could do a check like this. I almost feel like we are going to have to go through the entire string anyways. We're going to have to check each and every single character. Now, I also wonder, what if we go from the back? Like, if I go, let me see. If I'm in the front, and the first one is uppercase, the second one has to be, see, but that won't work. I think starting from the back is actually more important here, because if I start in the back and it's uppercase, that means the rest of them also have to be uppercase. If I start in the back and it's lowercase, what can we return? Only the first letter in this word is capital, like Google. Yeah, maybe we can start sort of like in the back. If it's uppercase, we just check all of them. If it's lowercase, we can just go all the way. Lowercase, go all the way. It's the uppercase one that's a little bit tricky for me, because when do I want to check the rest? Because it'd be nice if I can sort of just do all the cases in one go, right? Because you might be tempted to like loop through this string multiple times. Word consists of lowercase and uppercase English characters. I mean, we can check the first one first. So if U and G are uppercase, then either the rest have to be uppercase or they have to be lowercase. Else they just all have to be lowercase. Detect capital. But there might be a more clever way of doing this. That's what I'm trying to think of now. Because what are the giveaways here? One of the giveaways is for sure the uppercase at the end, because the uppercase at the end already signifies that all of them need to be uppercase. Lowercase means that some can be lower, but that first one, well, yeah, it's a little bit tricky. Only tricky in the sense that I want to do all three of these in the same go. All letters in this world are capitals, like USA. All letters in this word are not capitals, like LeetCode. Only the first letter in this word is capital. What if I had all letters in this world are capital. I can have like an all capital Boolean. I can also have a lowercase Boolean, all lowercase. If it's not all lowercase and not all capital, maybe I can do something like that. Yeah, I can have different variables like all capital, and I can start from the back. I can go from the back to the front here. When I get to 1, I can say if it's not all capital, yeah, I think I want to do that. Something like let all capital equals or true, let all lower equals true. If we do for let I equals word.length minus 1, I greater than or equal to 1, I minus minus. So let's see. If all capital is true, so if we get to a word, let's do this. Let's say const car. Const car is just going to equal a single word in here. So if we're going to use regex here, and we'll say like lowercase dot test car. If this is true, that means it is a lowercase letter, and that also means that all capital equals false. If we'll do the same regex dot test of car, all lower equals false. So we could do something like this, right? Because let's see what this gives us. We're only going from the last one to the first one. Here, I can say all lower is false, still all lower is false. Okay, and then we just stop there. So if I get to U and I say all lower is false, we define the usage of capitals in a word to be right when one of the following cases hold true. Almost needs to be like, this will only work. So return all lower, or oh, I guess it can be return all lower or all capital. No, because we're only going up until this point. So we still need to check that first one. Like if it's all lower and this one is fine, it's almost like 3 cases. It's like all lower and I guess the first, also this holds, word of 0. Or it can be all capital and a z test dot test word of 0, or see all capital, or the same thing. This can also be the same thing here, or all lower and a minus z dot test word of 0. I almost think like something like this can work. Because if we're going through this, again, what is it that we're going to be doing? All lower will be false, but all capital will be true. So if all capital and a through z of test word 0, that's fine. Or we get to all lower, and this last one is either of them, then that's fine. And I guess we can combine these. We really could combine those, right? Let me see if I return this, what happens. That's true and true, but we can do a little bit better here. We really could combine these. This should be a through z, and we can remove this. Right, because this could be a through z or a through z for that first one. And then for flag, let's see what we get here. True and false, true and false. So if we submit this, let's see what we get. Okay, nice, 84.37. Yeah, so probably, I guess we could have, the reason I started from the back is because I feel like the most important character is the first one. So we'll just be checking all the characters up until the first index. And then it just comes down to a second index. If all of them are lower and the first one's either lower or upper, that's fine. Or all of them are capital and the first one's also capital, then that's cool too. So I mean, I feel pretty good about that. Time complexities here is linear since we're only ever iterating to our string once. Space complexity also seems constant to me. However, I mean, we're only testing a single word here, a single character. So let's see what the solution is. Fairly easy problem because it does not require you to use any special trick, and all you need to do is implement the solution step by step. Beautiful and short, below two approaches are introduced that are character by character method and regex method. The problem gives us 3 patterns and asks if the given word matches any of them. It will be easy to think of checking the cases one by one. In each case, we can just use the most simple method to check if word matches the pattern. Check the car one by one. We need 3 bool variables to store if the pattern matches or not. The code is a little long. Don't be afraid. It's fairly easy to understand and we'll shorten it later. Yep, that is long. Okay, where to start? The biggest problem with the code above is there are too many cases. What if we combine them? Notice that the biggest difference between case 2 and case 3 is the condition of the first character. We get a new pattern. No matter what the first character is, the rest should be the same. Or rather, the rest should be lowercase. Okay, which is exactly what we did for this last one here. We need to use the first two characters, check if the word matches case 1. There's a ton of stuff here. O of n and O of 1. We only need constant space. Here we have regex, AZ, where AZ represents one character from A to Z. So it looks like pretty much the same. Oh, okay, then I guess, interesting. The speed of the regex is highly dependent on its pattern and its implementation, and the time complexity can vary from O of 1 to O of 2n. If you want to control the speed yourself, using approach 1 will be better. Yeah, so I feel like our solution is more like solution 1, and I think that's fine. I think that's exactly like what the question wanted us to do. Cool, so let's get to the next one. Kth largest element in a stream. So design a class to find the kth largest element in a stream. Note that it is the kth largest element in the sorted order, not the kth distinct element. Okay, so we do kth largest 3. No 4, 5, 5, 8, 8. So how is this working? 4, 5, 8, 2, 3, 5, 10, 9, 4. We add 3, we add 5, 10. Wait, how is this working? 3, 5, 10. And what is the 4, 5, 8, 2 here? Oh, the third kth largest of this stream? Or wait. Initializes the object with the integer k and the stream of integers nums. Appends the integer value to the stream. Oh, I see. So we add 3, 5, 9, 4. And here we end with 3, 5, 5, 8, 8. Output is kth largest element in a stream? And how is this the output here? The kth largest element? There will be at least k elements in the array when you search for the kth element. Okay. Oh, I see. Okay. So we add 3. The kth largest element is 4. Yeah, this is a little bit confusing, but let's see. If we add to this one, I mean, this one's a little bit tricky. What's like a really good way for us to get the kth largest element of something? I think there's something called quick select that we could use for this. I mean, we maybe could use like a heap for this, but every time that we're adding, like we can initialize our heap. That's going to take n log n to initialize our heap using that stream. And every single time we add something, are we also going to have to like pop off the heap to get the n largest one every single time? Could that be a way of doing it? That's one of the first things I think about. I kind of just want to see if this is okay. So it does use, but then we also have a binary search tree. Yeah, I feel like a heap. Yeah, heap's probably the way to do it. But every single time we add, so we're gonna add something to our heap. But then, do we need to actually? Yeah, this seems like a pretty. I don't know about a tough question, but I think it requires. Like I feel like there's a nice, like, I don't want to be popping off my heap every single time or having to do like 3 pops of my heap every time I add something to get the third largest thing. Because that's also going to be removing numbers when I don't want to remove anything. So I think anytime we add to the heap, we also need to store the numbers in a separate data structure that maybe will be able to help us like quickly access previously large values, if that makes any sense. Assign a class to find the kth largest element in a stream. Note that it is the kth largest element in the sorted order. So if we have 4, 5, 8, 2, and this sorted is what, 2, 4, 5, 8. If we add 3, so the kth largest, what's the? I would almost think it's like, yeah, 4, 5, 8, 2. Oh, okay, yeah, the kth largest is this one, and then we add 5. We're gonna put 5 there. Oh, wait a second though. It's always the third one, isn't it? What does that mean? Like if I do... I think I see what we can do. Maybe. Well, we'd still have to maintain the ordering of our array. But it'd be nice if like this array was always sorted. I know it's always the third largest. And I can use a... Whoa, I don't even have to use a binary search tree, right? I can always know if I add 5 to here, and this is already sorted, I just return the length minus 3. And here I would get 5. If I add 10, I would still get 5. Right, exactly. If I add 9, we would get 8. So now it's a matter of how can we keep this sorted, but sorted like efficiently. I guess a heap could help with that. But how does the heap... Yeah, it can't be... Yeah, it's tricky. I feel like the heap is a nice thing that we can use to keep this array sorted, or we can keep a data structure that maintains these elements sorted. That seems like the best way, at least with our tools that we have now, only having done easy questions. But my thing is being able to then retrieve a number without having to pop off my heap. Because you might think if it's like a max heap, I can just like pop 3 times every single time, but then I'm left with this, right? I'm actually like removing things from my heap. I don't want to remove anything. I want to keep it. Of course, we can do something really brute force where every single time we add, it's n log n, but that sounds really inefficient. Right? We can do a quick sort every single time we add and then just return the number at length minus 3. I mean, honestly, that really should work. If I do something like this.nums equals nums, and then this.k equals k, let's see, we could do this.nums.pushVal, and then this.nums equals this.nums. Does I don't remember. I don't think sort actually. Yeah, so we can just do this.nums.sort AB. Whoa, I'm all over the place right now. A minus B to sort it in ascending order. And then we just should be able to turn this.nums. Let's see, return this.nums at this.nums.length minus this.k. I definitely don't think this is the best way to do it. Like, even if this works, yeah, this is, I can almost tell you 100% this is not the best way to do it. Let's submit this. I'm just curious to see what we get. Yeah, look at that. I mean, it's taken a pretty long time. It might even be time limit exceeded. Because every single time we add, we're sorting. We're incurring an n log n operation for every n. Yeah, 5%. I think we mostly got lucky. If this was a medium question, it definitely wouldn't have run. So what's a faster way of doing this? Every time I add to my... Every time we add to the heap, how can that help me? Like, I know the heap is going to help me keep things in order, but I can't actually access the elements of the heap. JS priority queue. From array on queue, front, back, size to array. But to array runs how long? Yeah, in n log n. Yeah, that's the same thing. Even if I try to get the heap and then also convert it to an array and do the same operation, it says up here it still takes n log n runtime. So that's probably not the best way of doing it. Now, the topics that we saw earlier, it says binary search tree, binary tree, and a data stream. So I wonder how using a binary tree here, I mean, we can add things in the binary tree itself, and then every single time we want to find something, let's think about that. If I have like a 4582 and I create a tree out of that, I mean, it seems like a lot. Binary search area, binary tree, and then anytime we want to get the third greatest one, yeah, we could just make this whole thing like if we construct a binary search tree here, and then every time we add, we insert it into our tree, and then we also look. Or maybe it's not even about that. Like, we know what the third largest element is here, right? Let's actually think about that. When we initialize this array, I know what the third largest element is. If we have 4, 5, 8, 2, that's what? That's 2, 4, 5, 8. The kth largest element right now is 4, right? What if I have an index here, and I say that's where the current number is? Now, the next time we add something, let's say now we add 3, so 3 is going to be less than it. And I guess if it's less, well, if it's less, I can just increase I, let's say, to get to the next one. If I add another 5, yeah, wait, isn't that? Oh, but wait a second. That's so dumb, right? Because I'm not actually, like, again, this is just, this is assuming that I already have this mechanism that stores my array. However, maybe I can use the heap for that. Maybe the heap can give me that information. Anytime I add something new to the heap, so okay, let's again go back. If I have a heap, if the thing I add is less than the number, I guess the I is still going to be, yeah, how do we get to the next thing? I think I might need to like mull this over a little bit more. I feel like it's a combination of maybe even using like a hash table or something, but it looks like they very much want me to go down the tree route based on these related topics. I'm just not quite sure how to put that in my head currently, at least. Let's go ahead and see what the next one is here, like intersection of two arrays. Given two integer arrays, nums1 and nums2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. So here, what happens if I just took the frequency of all of them? I have 2 1s and I have 4 2s. Here I have 1, 2. So what if it was just any number? Let me see. Here, how many numbers? I have 2 1s and I have 4 2s. Okay, so already that's not right. Like, I was gonna say if the frequency is divisible by 2, we can add it to our output. Or we have 2, yeah, we have 4 2s. Or 2, we have 4. But that's not gonna work because 1 is 2, but it's still only in one array. I think what I can do here is we take the frequency of both. Once we have the frequency of both, it needs to be that, let's see. And we still only want it to be a distinct amount of times, right? Because I can say 4 is here. Like once I do the 4, I can't also add the 4 the next time. If I say, okay, I'm at 4 now, I see it appears once here. And it also, well, here it appears twice. So am I missing something? Oh, but 4 appears once here, appears twice here, but it at least appears once. So we can add it once. So it's mainly, I guess it's just the minimum of both frequencies. That's how many times you add it, as long as it appears in both. So let's think about this. You may return the result in any order. Definitely think we need the frequency of both of these. Now I'm just thinking about how to do something with those frequencies. Nums1 is 495, nums2 is 94984. So I see a 4, I see that it appears twice in the other one, that's fine. But then when I get to, I guess we can just take any one of these. I see a 1, does it appear here? No. I see a 2, it appears in there. I see another 2, it appears in there. But maybe every time we find one here, we also remove it from there. So I see a 4 here. Okay, I can remove it from there, but that's 1. Then I see a 9. Okay, I see a 5, that's fine. If I saw another 4, I would also add it there. So let me see if that would work. What I'm going to do here is I'm going to say const generate frequency. This is going to take an array nums. It's going to initialize an object literal called const frequency. Here we'll say for const n of nums, we'll say that frequency of n equals frequency of n plus 1 or 1. And then finally, we'll just return frequency. Down here, we'll say, let's see, nums1 frequency equals generate frequency of nums1. Const nums2 frequency equals generate frequency of nums2. And then I think we just have to go through 1. What if I just went, so let's say const result for const n of nums1. Let's see, if nums2 frequency of n is not equal to undefined, let me split this. Oh, we can also say not equal to undefined and nums2 of frequency of n is greater than 0. Here we can say result.push n, and let's also reduce the frequency at nums2 frequency minus equal 1, and then return result. Let me see if this works. So we have 2 and 2. I'm so used to running premium. It's been so long since I've had premium, but I'll literally like spam the run code button. Okay, we have 4.9 and 4.9. Let's submit it. Awesome, yeah, 93.15. Yeah, very cool. The classic question of using object literals to be able to keep frequency of a number. I just created this nice little helper function that will just generate that frequency for us. We create frequencies for each one of these, and we start off with our result variable here. Really all we're saying is we look at one of these numbers. The reason I'm doing the -1 is because like here you can see it's 495, but there's 2 4s. So we see that there's like we need 1 4 from this one. Is there at least 1 4? Yeah, there's 2. Okay, so we use one of them. Now there's only 1 4, right? Because if this had another 4, we'd also expect to have 2 4s in the output. That's why we're doing the -1 here. So during this time, we're pushing to our result, and then we finally get our answer. So this right here for each one of these time complexities, really this is like nums1 and nums2 can be different lengths. So we'll say this is m and n. So we can say m plus n, and here this will be plus m. That's really what the algorithm is. So it's like 2m plus n just boils down to m plus n. And then finally for our space complexity, we are generating these object literal frequencies, which really, if this is, yeah, it says here the length is less than 1,000, so we probably just could use just like a fixed size array instead of an object literal, but I think this is fine for here. We have all these follow-ups right here. What if the given array is already sorted? How would you optimize your algorithm? If the given array is sorted, but like what given array? If both of them are sorted, then I guess what would we do? Like one thing that we could do is, I feel like the answer is using binary search somehow. Like we find a 4, then we do like a binary search on the other array and we see if we can find that same thing. So this would be n, I guess it would be n log n, or n log m, which will be slightly faster. Now it says here, what if nums1 size is small compared to num size? Which algorithm is better? I think that we want to do, I guess here, well, I guess for this one, since this is a O of 1 constant time access into the other hash table, I feel like the one that we want to go through is the one that is shorter. That's what I would imagine. Since this last piece is just going through any one of them, what we could do is choose the shorter one. Because the shorter one we can just go through and then still do the lookup, which is just constant. All right, so if we do the longer one, we're just having to loop through more things for no reason. What if the elements of nums2 are stored on disk and the memory is limited such that you cannot load all elements into the memory at once? I think this has to do with like an external sorting, or being able to like offload some data to another storage device and then read it in chunk by chunk. I'm not really too familiar with that. I'd love to probably look at a video and learn more and possibly implement something like that myself. But I think apart from that, we did pretty good on this question. I think we got a lot of value from it. But let me also add this to an ongoing sort of follow-ups list I have here. And hopefully we can look at this at some point in the future and think about these a little more clearly. So with that being said, thank you all so much for tuning in. I know it was a little bit late. I know it was short. I just had a lot of fun today with friends and family, but I'm glad we got to do a little bit short stream today. I'll see you all tomorrow, probably early in the morning, because it's my girlfriend's sister's birthday party tomorrow. So I'm looking forward to celebrating that with her. If you all listened to my stream last week, you know it was her normal birthday last week, but we just celebrated her birthday, no party. Tomorrow we're doing the party. So very much looking forward to that, and hope to see you all again tomorrow. Hope you all have a great rest of your day,